You're listening to Maveller's book, article, Progressive Web Applications or Portable Web Applications. Applications in the browser. Before I start, I'm wondering how much of you are graphical user interface coders. Regardless if you are using web as a visualization or some hybrid or cross-platform or native toolkits. Well, I know your feelings, bros. The GUI frameworks, techniques, libraries has never stopped to evolve. For the web, from simple pages with every time custom design and code to jQuery-based frameworks and components, responsive frameworks like Bootstrap, material frameworks, flat designs, fixed and fluid layouts, component-based frameworks, and so on. On Android platform, the recommended user interface concepts changed at least 3 times from the time I have been developing on it. I'm wondering, are you even experimenting with voice technologies or some other non-traditional interaction between the user and the software and the hardware that, given enough time to evolve, to educate the user, to improve the software and hardware, could potentially make the traditional GUI obsolete? Well, we'll see. Until then, we'll still have work to be able to provide for our families without a need to dramatically update our mindsets and skills. Before I get into what is progressive web application, I'll introduce a little bit of history. Internet has evolved a lot the last 2 decades. 25 years ago, the web was looking very differently. Most of the internet sites, web pages, were working synchronously, needing full page reload for every small change that needed backend integration. First workaround for full page reload was using the iframe, placing different URL to the third src attribute. Around that time, the idea behind asynchronous HTTP requests was first planted by Microsoft via the ActiveHX object. The ActiveHX object failed and is discontinued currently as technology, but the idea of the partial page reloading, the AJAX, was implemented by all browsers and is now an accepted standard. There were very few options for storing something on the client back then, without persisting it on the server, and one of the few options was HTTP cookie. But the persistence option had its side effects, making the requests a little bit slower, as it sends the data with each request, and the internet speed was in the infancy right then, and still evolving. It is still evolving today, but to much higher levels, with 4 or 5G. Another way was to store something was with request parameters, but this was visible to the user and not so user-friendly. So around 10 years ago, HTML5 made its first release. HTML5 is a never-ending evolution of web standards, APIs, and possibilities that made possible transforming our websites to a feature-rich platform. A decisive point was when Apple ditched Flash for HTML5 on the iDevices, forcing the whole industry to follow up faster and more radically. Facebook, Twitter, YouTube, LinkedIn, and many more didn't need a lot of time to move to it and to get started giving back their own contributions in terms of tools, frameworks, recommendations, source code, and implementations of improved APIs for the web. Google created Chromium. They gave money for WebM video format, and they open sourced it. For Chrome, they used V8 JavaScript engine that migrated to the server thanks to being open source. And Twitter gave Bootstrap, Apple the WebKit, that was the initial work for the Chromium project, the Google web browser. Getting back to today, the most universal platform accessible almost everywhere is the web. On some small special type of devices, it may be not with a web browser, but with some custom socket or HTTP protocol, but they are mostly very specific and custom. The bigger majority of devices are having a browser, even smartwatches, feature phones, smartphones, tablets, laptops, desktops with whatever operating system. Google is even investing in making their browser as an operating system shell, making it an internet-first laptop. The internet is accessed all over the world, even the third world countries where the power supply and the internet connection speed is not so good at this time. Partially because of this, there are some initiatives to package the popular Western services in light version that use less storage and data. From developer point of view, we have HTML5. That is more than just several tags that integrate audio and video or bring some more semantics to the page structure. HTML5 includes in itself the evolution of the JavaScript and many APIs accessible through special classes accepted by the web community that bring a lot of the features previously accessible only through native API and applications to the browser. Progressive Web Applications, or PWA said shortly, is HTML5, the APIs in the normal scope of a web page, plus the service worker features that are JavaScript APIs that are running, that are executed outside of the normal web page workflow. You will probably find on the web that the service worker features are the thing that bring the progressive, but I think it will not be so feature rich without the HTML5 APIs, the APIs that bring the sense of an application in the abbreviation. PWA is about security. That is why most of the more advanced features work only over HTTPS. PWA is about speed. There are million ways to tune up the speed or even the visual sense of the speed. I will point out some of them. PWA is about application reliability. It will work offline and will fail gracefully when that happens, giving more meaningful messages. PWA is about engagement. What brings back the users are very often more psychological factors. But whatever technical ways there are to get the users back are somehow included in the PWA. Notifications, work offline, speed, and many more. Together, they are a package of APIs, tools, and best practices that take into the account the currently accepted web standards and a little bit beyond, plus taking into account how the HTTP works to try to make the best user experience as possible in several terms: application size, speed, usability, responsiveness, software and user interface quality, and so on. The idea of a progressive web app is to try to satisfy the user and bring the best user experience as a web page could. Work even offline, engage the user into using the application, and in most cases, it is above concrete proprietary technologies, above concrete software packages, libraries, frameworks, languages, and browsers. It doesn't matter if you are plain JavaScript, if you use plain JavaScript or Dart or TypeScript or any other something to JavaScript technology. If your GUI coded or by you or generated by some tool or some framework. It doesn't matter what is your backend. PHP, Java, .NET, Go is the backend and front end strictly separated while you program. As long as the whole thing, the result, in the end, is following the current best practices. There are trade-offs, as not everything is suited for the web. There are many small things to tune up to work around the limitations of the web in terms of speed, performance, user experience, native features created every year, but it gives you true possibility to have one code base, or at least one type of, for all users and potentially all type of devices, instead of code bases for the browser, for Android, for iOS, for Windows, for desktop. The cost of having all these variations of native applications will surely be a lot more than just the web designed to adapt to different screen sizes and devices. One key thing of PWA is speed, is making every single thing non-blocking, as synchronous as possible, as long as it doesn't hurt the user experience. There are scripts on the internet about loading JavaScript and CSS after the page is loaded. So for good user experience, the sense that the page is loading, the very basic styles, images and scripts could be included inline at the very beginning, and everything else could be loaded after that. This drives functionality modularization, besides the startup speed. Minimize image size. Use SVG and CSS features like repeat for stripes, like covers, transformations, animations, joint images that are later grabbed with CSS background image property. Use thumbnail versions, images with the exact size as they are displayed, and request the larger one when necessary. Use better compression, like progressive JPEGs. Use server HTTP feature to download multiple images in one connection. That is HTTP pipelining. Another thing that brings speed is minimize the number of objects created by JavaScript code that increase the memory overload. One approach for doing that is the Android list view pattern that is implemented in Angular 7 as a virtual scroll. There are probably other implementations of this pattern in other frameworks. Another visual thing that Google learned from past experience, or maybe not, is delegating the UI creation to the layer that will do it best. It is separation of the UI code from the logic. The idea is implemented in several Google children, like Google Web Toolkit, Angular, Android, probably others, but not sure why not yet in Flutter. For the web, in Angular, they separated the UI code in HTML files, and it is the best place to design your DOM tree instead of making the DOM tree from the JavaScript. Loading what may be appropriate according to the needs of the applications with a high priority offline from the file system or application cache with the web worker. And with this will do it with no backend hits, with no backend requests. Another semi-good way is to request it with to place cache control HTTP headers, making very minimal requests about any need for update, and only place no cache on items that are very often updated, like could be some endpoint that you check for new versions. Offline functionality. Do you know well the target client, the needs of the end users, to know what approach to use? There are cases like business applications where offline functionality is not necessary and even bad, like business-to-business software, but in most cases it is good. The percent of mobile browsing is around 50%. From the desktop devices, there are also a lot of laptops, and very realistically, they are used in non-on-top-of-the-desk environments with high-speed connection to the internet. So, in practical terms, there are several APIs for checking internet. Navigator.online is the developer could check what to do if is online, if the user is online or not. There are listeners of the internet connectivity, and you as a programmer could do something when these events occur. And the service worker could do something in case there is no internet. This is using interceptor, filter, controller pattern to separate the choice of operations when the user is offline or online in one place, instead of every place where a backend code is executed. Storage information options. Cookies, key-value storage shared between client and the server. File system. It is still a draft, not a recommended, not a worldwide standard. Local storage. It's offline key-value storage. Web SQL. It is SQLite in the browser, but is discontinued recommendation and not accepted by the consortium. IndexedDB. It is the most structured way of doing something in the browser. It is a transaction-based indexed SQL-like, no SQL accessible from the service worker even offline. The values of the indexes could be strings, objects, blobs, and so on. Drawing APIs. Canvas for 2D, like drawing simple 2D stuff, lines, squares, circles. WebGL for 2D and 3D is for more complex shapes that use the provided by the browser implementation of OpenGL that could give potential boost to speed using hardware acceleration, and so on. Push notifications. Web push notifications take the experience from native mobile push notifications and bring them to the browser. The workflow is identical. Get user permission to receive notifications, save the registration when something new arises, and the server sends a trimmed info, a small message to the gateway with the registration token, and the message gateway transports it to the device, using only the browser as application receiver instead of native application. Background fetch or background sync. These are still worldwide consortium drafts, and they are implemented in Chrome, for example. These are APIs that you could register some work to be executed outside of the normal page window scope. It may be useful for like downloading a movie, sending some information when the user is online, and so on. It follows the same restrictions introduced in the mobile platforms, like iOS and Android, to not run forever on the background and drain battery, and will wake up only on some special events and will run shortly. Media devices APIs. Media device APIs give you access to the camera, and you could use it for image photo manipulation or even barcode reading. Access to microphone, used for example for in-browser speech recognition. Access to GPS location. A user may give access to a web application the values of their GPS sensor, useful when running from a mobile device. Native performance with WebAssembly. WebAssembly is stripped down stack-based virtual machine that translates the provided bytecode WASM to more close to the hardware machine code, useful for games and heavy mathematical computations and so on. Application developers like me, using some higher level programming languages and abstractions, abstracting all hardware and software complexity, we sometimes forget that in the end all is stripped down to mathematical operations. WebAssembly is just a VM designed to be not too complex from the start, so it may be more easily secured, and with some basic idea to be adapted for the internet age. It is not a new language, but a trans-compilation target already targeted from higher level languages like C++, C#, Go, Java, and other frameworks to get the boost from the native-like performance on the browser instead of the interpreted JavaScript. Currently, it is more for toolkit and framework developers and for some very specific developers of some very specific applications that could get the real boost from using it directly with having their hands dirty. As I heard from nerds2nerds.com podcast, WebAssembly is also being ported to be used outside of the browser, and this may boost the backend use of JavaScript or some other usages. When opened normally, the navigation bar of the browser is visible and accessible to the user at his wish. One PWA feature is to create a desktop shortcut to your site, and it will launch your site in a browser session, but will remove the address bar, making it feel more like an application. One thing to point out is it is a good idea to introduce PWA features to sites that are designed to have the look and feel of an app. Otherwise, they will look like a chimpanzee with a lipstick. Permissions. something available in Android 6.0 and beyond, and iOS not sure from when. Every access to some more intimate sensor or functionality requires permission from the user. Use of more storage and memory, camera, microphone, push notifications, GPS location, and this is how it should be. No website should have default access to this stuff. On the web, requesting permissions has the same user experience best practices as on the native application. Ask for them when they are truly needed, not on first page load. Today, there are a ton of stuff that is poked to the eyes of the users. Cookie privacy policies, ads, logins, pay now features, and the permissions and push notifications and add to home screen are just few more things to the already overwhelmed users. There should be some romance, some dating before you propose something serious to the user. So if someone tells you he programs business applications in HTML, don't laugh at him, because you probably have not updated your information what is available to developers in the browser. It is not just the simple markup. And yes, you probably not hack NASA, and not everything is perfect. Not everything is supported everywhere. Sandboxing, making software secure is not an easy, and it is even endless task. But time is not going backwards, and you probably not need to support Internet Explorer 6, for example. It's for example like Apple lagging to implement all the PWA features from one part that is troubling, because they are not all up. They have not done it because they are all the new features are currently not yet all approved by worldwide consortium. They are not all standards, but there another reason is that when accepted or implemented, they will hurt the income of Apple coming from the App Store, while the openness of the web pages allows Google, that monetizes from the content scraping, will have a little bit less technical woes to access the content in the applications, and that is why they are pushing so much the web for new web improvements. You could check what is available on caniuse.com in general, but as defensive developer, you could see if some feature is provided by your current browser with ifs, like if the string service worker is in the browser, then do something. If navigator.geolocation is null, then do something. And you could add some workaround or some message very user-friendly accordingly. I am not able to currently tell you that I have a PWA. I am not able to currently tell you that I have a PWA application in my personal projects, but there are work in progress, so sometime soon I may have the possibility to show them in a ready for the public examples. In my personal blog, tomorrowvalue.com, I have implemented the asynchronous loading of CSS and JavaScript. I've experimented with 2D drawing library to visualize the relations between different stuff related to food and health. I have used Google Voice Text Recognition for entering ingredients of food items, and this feature was even 6 years old. And the functionality is currently not working from the official domain, but will be after I finish the PWA transformation. So basically, that's why the browser use of memory is going to increase more and more in the future. I hope that the browser session and the information about application are going to become separate in the future, so it may be easier for every user to clean up the data for some specific separated site instead of having all the resources for all the websites cached in one location and unable to clear resources for some specific application.